Okay, so we're going to do the second part of this question. So in the second part of this question, I want to know how long it takes the ball to hit the ground. Now, there's a lot of ways of doing this. There's a shortcut, fast way, but I'm going to do it the way that most people can picture it when first starting out. And that is by finding the time up and then the time down and adding them together. Because I know the time up is going to be a lot shorter than the time down because it only goes up this distance, but it falls a lot further because it leaves his hand and drops for further. So I'm going to start up with the up, right? I'm going to start with finding the time up. How long does it take to go upwards? That does not look like a U. Okay, there we go. So I have all the data for up, right here. I have all that stuff. I'm just switching to time. I'm not going to use my distance in this case because I don't need to. So I'm going to pick an equation and I'm now going to find time. So I'm going to find V2 equals V1 plus t. I'm going to use this equation. V2 is 0, V1 is 5.10, and my acceleration is negative 9.8, slowing down on the way up, and I can solve for my time. Not too hard, not a lot of steps, love it. So this is going to come to the other side and become negative. Our math skills should be getting pretty good by now, right? Because we've been doing these equations for a while. And then I'm going to divide this over and I will get a positive number. You'll notice I don't get a very big number. However, that is not surprising, right? Balls do not go up for very long. You throw a ball up in the air, it does not take very long to fall. In this case, I've got 0.52 seconds. 2 sig figs because of the 9.8. I could keep an extra, but my next one is a 0 anyway, so I'm not going to get overly excited. On the way down, when I look at down, I now have to think about what's happening. Now, as it falls, I'm not going to worry about going up anymore. I'm going to think about falling totally different. Remember, when it gets to the top, it's going to stop and pause just momentarily. And because of that, falling down, V1 is 0. It's just like dropping a ball. It's also going to speed up on the way up, or way down, because it's now falling. Falling things speed up. And I can now use this. I'm going to have to use this as my height because I don't know the V2 and I don't know the time. So I'm going to use this height. I don't usually use things that I calculated, but I'm going to in this case because I have no other choice. It's the only other piece of information I have. So I'm going to believe in my own personal abilities and my math. Now I can find my time, right? I'm going to pick my equation. This one is the one that has everything I have plus everything I need to know. We'll use this one a lot when we're doing these. I've got 2.5. Velocity is 0 to start, so 0 times t is still 0. 1/2 of 9.8 times t squared. There we go. So my math writing, there we go. So now I have 2.5. Half of 9.8 is 4.9. That 0 goes away. And I can then solve from there. So I will, this is 0. So I end up with, I could have simplified that a bit more in the previous step. Sorry. We'll simplify so you can see it though. 4.9 is going to divide across. So I'm going to go 2.5 and divide by 4.9. And I will get 0.15, etc. But that's t squared, so we're not done yet. I need to take the square root of that to get my answer. So my answer should really be 2 sig figs, 0.71 seconds will be my time. Then all I have to do is add those together, and I have my total. And I am done. So 0.71 seconds is my time, and then I'm going to total them, and I will get my total answer. My video might stop at any second. If it does, we do understand what we've done, so